So the objective of this lesson is I can evaluate the end behavior of a given function, and we can also interpret this as you can evaluate the limit as the input approaches infinity. So some vocabulary. First, we have end behavior. So this is describing what happens to the value of a function f of x as x goes to negative infinity and positive infinity. And then a limit, you're probably wondering why we're talking about limits, which I'll explain in a second, which is the third question really. But a limit is the value a function approaches as the input gets closer and closer to a specific value. Sorry, I paused because I was reading this over and I ended up using different phrasing. Anyway, so the reason we use end behavior in pre-calculus is because basically we are usually describing the behavior of a function. So suppose we had a function that just went like this. And we were talking about the end behavior. The end behavior is this part and this part here. So the end behavior describes what happens as we move right or left. And as we move to the right, that means we're going to infinity, and as we move to the left, it means we're going to negative infinity. So the point of the limit is that this is the same as taking the limit as x approaches infinity of f of x. This is the same as x goes to infinity, f of x goes towards, it's the same as that, and the limit as x goes to negative infinity of f of x is the same as when x goes to negative infinity, f of x goes to something. So if we were describing the end behavior of this, the end behavior abbreviation would either be as x goes to infinity, f of x goes towards infinity, and then as x goes towards negative infinity, f of x also goes towards infinity. The idea is as x goes to the left, x will go towards positive infinity, and as x goes to the right, f of x will go towards positive infinity. Sorry, I said f of x will go towards positive infinity before when discussing as x goes to the left, but it was supposed to be positive infinity. Okay, the other way you could also do this is you could say rise right, rise left. That also works. And then the limit notation, which it's good to learn if, especially, no matter what math class you take, even if you don't take calculus, you would say the limit as x goes towards infinity of f of x is infinity, and the limit as x goes towards negative infinity of f of x is infinity. So these two go together, and then this goes together. I just want to make a point to really talk about the notation. And just a really quick note, the limit notation here means as So as we plug in really large values of x, f of x is approximately some value, and that's the limit as x goes towards infinity. Then the limit as x goes towards negative infinity. As we plug in small values in for x, f of x is about. So that's the limit notation and how to interpret it. And also a general idea of how to think about it too. Okay, so here we're going to describe the end behavior. If it helps, start like this. Say rise left, fall right. I think this notation is easier than the first one I showed you. It's a little bit more vague, but it works in colleges. So rise left, this is the same as the limit as x approaches negative infinity of f of x, which is going to be positive infinity because it rises. Fall right, the limit as x approaches positive infinity, because we're going right, of f of x, is negative infinity. Also, just a note here. We figured out it was going to rise left because all the way to the left, it's rising. This is the furthest part on the graph. That's where the rise left comes from. And then the fall right, that comes from this part here. Because as we go to the right, we end up falling. Okay, so let's look at our graph. We're rising to the right here. And we're also rising to the left here. So we'll say rise right, rise left. So this will be the limit as x approaches infinity of f of x is positive infinity. This will be the limit as x approaches negative infinity of f of x is positive infinity.